Hey going, Landon here from Zero Grid. Just checking this thing's working, but yeah, I just wanted to make a video about building off-grid systems, and I'm going to separate this into sections. And this one I want to talk a bit about the planning stage. So I feel like it's a most important part of the build, and really, like, for reliability, we want to have the correct size components, the correct size cables and fuses, and also a well laid out board. And the reason why we want these to be well laid out is to keep them cool and the way that we can. So any idea that you have to keep things cool is always going to be a great idea. So sometimes when I mount these solar chargers and stuff like that, I use standoff bolts, which are like a little shaft, if you like, that keeps them up off of the deck a little bit further, and that increases that airflow behind. And sometimes we introduce fans and that type of stuff. So this here is a board that I'm putting together for us. We've been living in our bus for 4 years and on a system that I built, and it was the first one that I've ever built. But now, after building maybe 25 boards for other people, I've sort of come a long way and build things differently now than I did then. So, and I'll show you some before and some after photos as well, if I'm good at superimposing like a before and an after type thing when it's done. But with keeping them cool, like, the manufacturers always have the specifications on distances on how to spread them apart, and we do our best to keep to those. And this is our board, and it's it's got a multi-plus 5 kVA multi-plus 48 volt, and they recommend 100 mil clearances around it, and we can't quite get that. We're limited in the space where I need to fit it, and the compartment and that type of stuff. So what I'm doing is I'm bringing that down to 75 mil, and what we're going to do is then introduce some cooling fans as well, just to encourage that air through. So if we're compromising it in one area, we sort of need to make allowances for it in another type thing. And when I do cooling fans, I like to do two fans, or one fan and one vent, and I have one up high on one side and one down low on the other, and either a fan pushing and pulling, either 2 fans or 1 fan, and just to encourage that cross ventilation type thing to move the air across and out. So, and also with laying things out, I like to space things the hottest components at the top, and the reason being that if we have a part that's going to be running at full capacity down the bottom and getting hot, it's going to then heat up the other things, and they start to deteriorate, like lose their performance as they heat up. So especially DC to DC chargers, DC to DCs run at their full capacity. So like a 30 amp DC to DC is going to be pulling 30 amps every time that it's on, and it's going to be pulling it flat out. So if I have a DC to DC in the system, I'll be mounting that up top. So then that's the hot air will rise and go through, because these allow utilize the cooling fins on the back of the air moving past them to keep them cool. So it's going to be heating up all the other components. So DC to DC is up the top if we have any. This system doesn't. This is our system. We've got 2 smaller solar chargers, 150-35s, to do the 2 strings on the roof of the bus, and then I've got one bigger 150-70, which is going to do the 4 big solar panels on the trailer. So that's and that's why I'm rebuilding this board, just because we're introducing that trailer with the solar panels on it, and it wasn't originally part of the plan. And this doesn't have a DC to DC charger on this board, and I charge through a different way off of the motor, and I can explain that in a different video. But with laying these out as well, like, it's important to keep that spacing, and to keep things as cool as possible, because they all deteriorate their performance as they get hot. So the more we can space them out, like if I had 2 meters of space, I'd have 150 mil gaps, and I'd space everything out nice and long, and have fans and all that type of stuff. And that's how we're going to get the system to last as long as we possibly can. But it's also important to keep allowances, or keep in mind about segregation of AC and DC. So this is going to be my DC side. So in the multi-plus inverters, on the right hand side is where the DC connections are. So that's just your positive and negative cables from your battery bank, if you like. So that's going to be on the right hand side, and then on the left hand side is where all your AC cables come out. So if I was building this on a single board, I would try and have the MultiPlus in the middle, and then I'll try and put the DC connections on one side, so with, you know, like any like main breakers and, you know, solar chargers and all of that type of stuff on one side, and then I'd put the AC on the other. But this board, I'm doing a bit of a around the corner jobby, and I'm going to have a little AC board on the side wall in the compartment, so I'll be able to show you some photos of that as well. So some of my favorite components to use these days, which I probably didn't at the start, is these ones, like the Lynx Distributor, which I didn't originally use these because they're such a big component. So I don't know, I do have a tape measure, but you can also Google it, I suppose, but that'll probably like 220 mil by 150 mil, maybe something like that. So almost an A4 sheet of paper, and sometimes they're just a bit too big for, you know, making little systems and caravans and motorhomes and stuff, but I really love them on these systems. And what it means as well is that if I want to add more 48 volt loads down the track, it's easy to. So I can just whip this cover off, I can add in another fuse and connect up the cables, and away you go. So say if I wanted to put in a 48 to 12 volt converter for some 12 volt loads or something like that down the track, I can easily do that, so which is always handy. Also, I think something that, you know, to help people out building their own systems that we've created, or I've created, is these wiring diagrams. So on our website, we've got a whole heap of wiring diagrams, and the biggest fault that I see is probably incorrect cable sizing and fuse sizing. So, and a cable that is undersized is going to, you know, under load, it's going to have a voltage drop, and it's not going to work as the system should. So everything's going to be seeing the wrong voltages, and it's going to struggle. It's going to think it's fully charged when it's not, and all of that type of stuff. So having the right size cable. And when it comes to sizing cable as well, there's no real such thing as too big. So the only, you know, area of too big is if it doesn't fit into the terminals on the solar chargers or the DC to DCs. But we can always have like inline step down lugs, or like a terminal post with two lugs on it. I'd probably avoid the terminal post. The less connections, the better type thing. So, you know, but there's ways around it as well. So say if the calculations work out that you need like a 35 mil cable, there goes my wiring diagram. If the calculations work out you need a 35, and 50 mil cable is a whole of 50 cents a meter more, I'd go the 50 mil and run that type thing. And that's where I, you know, where I can, I upsize the cables, and that's where it, you know, helps the system to stay running cool, and it's going to help us over that long period of time, and also even future proof. You know, it's if you're putting in say a 2000 watt inverter, and you're sort of on the edge if you're going to go a 3000 watt, you know, run the cables for the 3000. The 2000 is going to love you for, and then it's going to give you that option to easily upgrade to that 3000 further down the track. So yeah, it's about laying these cables. So I use this duct, which is like a slotted duct, we call it, and it's like I don't know, 50 mil by 50 mil, and it's a good way to keep things neat, building a system and laying things out. So I put the duct in areas and in ways that, you know, that this one's down low, it's going to have the connections to the MultiPlus, but then also the connections from the battery are going to be able to come in this side. So laying the cables in the duct is a bit of an art to keep it nice, and sometimes they, you know, I feel like some people use duct to throw things in and hide things away, and we definitely try not to do that. So so my best tips for laying cables in the duct is to lay the furthest cable away first. So say I've got, you know, this one here is where it comes out of the solar isolators and it goes to the solar charger. So that's my furthest run. So I'll run that one first, and then I'll start, and more than that one, there's a short one, and then I'll start running these ones. So the furthest one first, and then the nearest one. So that's my like battery connections, if you like, from that bus bar. So and probably like I've got a few cable ties here, just to bundle them together. So it's definitely, it helps you building the system as we go on to keep those cables as neat as possible. And that's because there's always something, a cable that we're going to forget. We're going to forget a V direct cable, or we're going to forget a CAN bus cable from the batteries, or something like that, and it's going to need to go in on top. So just to start out neat is the best tips, and I like to bundle them together. So I've bundled these together. These are sort of like my battery connections to these two solar chargers, and they're all cable tied together. And what I've done in this system, because this is rebuilding our system, that I need to pull out our MultiPlus and our solar chargers to then put this together and to put it back in, and I got to do that same day, because we rely on our system every day of the week to be running all of our loads. So I need to wait for a cool day, we don't need air conditioning, and a day that the wife and the kids are sort of happy to go out for the day or hang out outside or whatever with no power. But what I've done is I've made my little very official looking cardboard templates of the solar chargers, just so I can lay them out, and when laying them out, it's always good to keep those distances, but a real trick to keep them looking professional, I suppose, these systems is about having equal spacing. So I have two ducts here, and what I've done is the gap between these two ducts is the same as the gap between the top of that duct and the top of the board. So that's equal spacing. It's pleasing to the eye to have these lines straight, and when we can, we sort of match up the tops of components. So here I'll have these two solar chargers match up with the top of the Servo GX, which unfortunately I can't have the solar isolator box in line, but it's going to be pretty well there. So and even little things like keeping these spaces, I've got like maybe 30 mil there between the solar charger and the edge, and I'll do the same with this top one, and then I'll try and use 30 mil as the same spacing between those two in the top, and within this distance I'll have the solar charger sort of in that central location there as well. So I think that's about all I can really think of about the planning stage. But just to go over the the important parts, and that's around having the correct size cable and the correct size fuses, and that's what I've created these wiring diagrams for, just to really be the chicken before the egg type scenario, and to make sure that we got these things right. But my other tip is to take your time, and it's really it stops us cutting corners or using the not quite right tool or lug or cable type thing. So for me, like I'll lay this out, and I'll put just even pile them up, solar chargers with my isolators, and then I'll have the solar chargers with the V direct cables and bootlace terminals, to make sure that we've got all the right things, the right lugs and that type of stuff, even before I start. So that's all I can think of there. Probably another trick that I have learnt, and that is to cut the duct separately to the lids. So sometimes, especially where they join, and I'm not a master of this, but I'm getting better, but sometimes we need the cover to be a few mil longer than the duct itself, just to have that nice gap. So that's a really good way to do it. So I'll just have a whole pile of lid there, and then I'll just measure it up and cut that separately. So I just use a set square and a circular saw just to cut that slowly, and for cutting out the hole, so I've cut out like squares in the duct here, and where the solar breakers are, I've had to cut out a big hole, and I use like a multi-tool with like a wood blade. Even a metal blade would be fine. It's pretty thin plastic, so it'll chew through that all right. So that's how I get nice neat holes there. With cable ties, they a super handy trick to have, and I'll just I'll show you, is that to use a set of pliers, and where the cable tie comes out, instead of like cutting them off roughly, what we do is we grab them and we twist them, and it pulls off. And what that does, it creates like a smooth edge rather than a rough edge. So you can also buy like they're called like flush cut side cutters, and they've got like a perfectly to keep them flush. But even then, sometimes it's hard to get the flush cuts in. So I don't even have a set of flush cuts. So I just use the Plyotrix, and really what we're doing is making sure that this is going to be, so the poor bloke coming along next is going to be not scratching his hand and cursing your name type thing. So that's a trick I can think of. Another one is the V direct cables in the bottom of some of these solar chargers. They're a bit of a painful connection. If you've used one, you know what I'm talking about, that they kind of sit in there with a whole bunch of good luck. So what I do is I put a little bit of a loop in it and then have a cable tie just to hold that one in. So that's always good. The other thing I can think of is on my cables, I like to use bootlace ends. So a bootlace end is a little connector. It's a bit hard to see. Funnily enough, it looks like a bootlace end, and what you do is you cut the cable back and you slide them over before they go up into the bottoms of the solar charger. And because the cables we use are flexible DC cables, they have it feels like 1,000 strands, but I'm sure it's not that many. But it's a multi-stranded. It's got a shit ton of strands. So these just help to stop them spreading out. And there's a bit of a division of electricians with if you bootlace or you don't bootlace, and I'm a bootlacer. So I think it keeps a neat system. They also look nice just to properly terminate it along the bottom, and sometimes I even then put a little bit of heat shrink just over the bottom of those just to sort of hold it all on there type thing, and it can look quite neat. So so that's on the connections. Probably another general rule of thumb that I was taught as a Sparky is to have incoming power into the bottom of the breakers. So the solar isolators I like to, and there's no reason why or why not, but I like to have the incoming power coming into the bottom. So it's a bit of consistency throughout the system. There's no particular reason, but I like to sort of pick away, and if you can't do it, you can label things to make it obvious as well, and that's always a handy thing to do. And I'll go through with the labeler, and I'll probably put the labels even on the outside of the Lynx Distributor just to be like solar charger A, and then it'll be this one, solar charger B to this one. And what I like to think about is that the person fault finding this, and I always think about like silly me in the middle of the night, when your brain's not quite working right and you're trying to work these things out, is to preempt that scenario and to make it as simple and well labeled as possible. So even little things that, like, I've got this solar charger is the right hand on the right hand side, and then this solar charger will be the next one on the right hand side, and then there'll be the left hand side. So it's just a little bit of consistency. So then when testing, you can have a bit of a visual check there. So to make things as obvious as we possibly can, and it's not just for the middle of the night users, it's also for the next users. Like one day we might sell this bus. I kind of doubt it. I think it'll be mine forever now, but we could possibly, and it's the next person coming along, it's good to have things obvious for them as well, so then they can sort of get inside of your brain to see your thought process. So yeah, that's about all I can think of. I think we've got the wiring diagrams, which really help with getting the right size cables and connections and that type of stuff. And they're also really good for listing out the components that we need for building these systems. Sometimes you forget about that you need a V direct cable from your smart shunt to talk to your Servo GX, or little things like that. So it's really to preempt that having to go back to the shops when you're halfway through building something. So yeah, I think that's about it. If you are looking for, bits and pieces of components, like things like the duct or, different cables and stuff like that, or even like enclosures of different sizes, we can get all that stuff. We don't list it all online, but reach out if that's something that you do need. But yeah, I'll make another video on, once the system's together, and anything that I've changed my mind on throughout the process of building it. Maybe once I get the MultiPlus, I can show some connections on there, and yeah, I'll keep you updated with how it's all going. So let me know if you've got any questions. Cheers, guys.